Hi, everyone. Tom Keelan here. Welcome to this brief introduction as to how to use the Metalog Excel workbook, which should enable you to find a Metalog distribution that corresponds appropriately to your data very, very quickly. To download the workbook that you see on the left-hand side of my screen, just go to the Metalogs worksheet, and under the Software tab, you'll see there's a Metalogs Workbook tab. If you click that, it'll take you right to a place where you can download this workbook, which I recommend that you do in conjunction with this introduction. So let me go now to what you will find in the workbook. First, on the left-hand side, you'll find a set of data. These are your input data, which are points on the CDF, which you can see here, that parameterize your Metalog. So in this case, imagine that we have a variable called variable 1 here. By the way, you could change that to variable 2 if you wanted to. And that would change the titles in the graph, but we'll go back to variable 1 for the moment. So you have your data here, and let's imagine these are an expert assessment. There's a 10% chance of being less than 25. The median is 40. There's a 90% chance of being less than 60, and then the expert gave you a couple of more points. There's only a 1% chance of being less than 10 and a 99% chance of being less than 90. Here you see a 5-term Metalog. The number of terms is here, and that's something you can change. That 5-term Metalog goes through all 5 of these points exactly. And in this case, it's an unbounded Metalog, and we'll come back as to how you can change that as well. The A coefficients, basically this Metalog here, the A coefficients that define that Metalog are shown right here, and the CDF, that is the quantile function, is plotted here, and the density function is plotted there. So let's and when you use this worksheet, remember that anything that is colored in light yellow, all your data and so forth, is something that you can change. Everything that's in green is something that's calculated automatically, and you typically would not want to change it or disturb it. On the left-hand side of this worksheet are all of your controls for boundedness, number of terms, what the bounds are, and so forth. We have something called regularization, which I'm not going to cover here because I rarely use it for smoothing out PDF, but we'll skip that for now. In the middle of this worksheet, we have a set of graphs. You can see the graph for the Metalog here, but here are thumbnail graphs of what the Metalog would look like if you used fewer terms in the Metalog panel. And then on the right-hand side, we have more information, and then everything basically to the right, pretty much to the right and below this where my cursor is. All these are intermediate calculations. You would not ever really have to go into this part of the worksheet unless you want to go through and see how it works. This worksheet does not contain any macros. It does not contain any named ranges. And so you can transport it into other Excel workbooks that you might be using by right-clicking on this Metalog tab here, click Move or Copy, and if you have another workbook open, you can copy this worksheet with its same functionality into another Excel workbook without disturbing any of the calculations in your other workbook, and this worksheet will still work correctly. So with that introduction, let's start. This data here can be any data that you put in. You could erase that, start over with whatever your own data might be. And you can have any number of these data up to 10,000 in this particular worksheet, although fewer than that is what you would probably use. Let's add one more data point just for interest. Let's say you did a second expert assessment of the median, and where previously he had given you the answer of 40 for his median or her median, let's say he gives you the answer of 50 this time. Well, what happens? Well, those are two inconsistent, those assessments are inconsistent. They correspond to 2 data points here, but you can see that the 5-term Metalog immediately adjusted to go pretty much right through the center of them, and then go through the pretty much through these other points as well. The A coefficients here would have changed, and if you're wondering how to interpret these A coefficients, well, they're not very easy to interpret, but in terms of quantile parameters, they're quite easy to interpret. For example, you might want to know what's the interquartile, the 0.25 number on this cumulative, and that's 35.1, or the 0.75, that's 51.6. And if you want to know what point on the cumulative corresponds to probabilities that are different from this, you can go over here and change the probabilities to which these numbers correspond over here around column A, B, and the first several lines of that for different numbers of terms. The other information that's displayed here is here are the moments of this particular displayed metalog, the mean, standard deviation, skewness, kurtosis. These moments are available in closed form for unbounded metalogs only, but as long as you're using an unbounded metalog, they will be displayed here. Here is a place where you can simulate, and you could make a table out of this and so forth. I've just simply got a RAND for a random number generator in this cell, and this gives you a corresponding simulated value off that metalog. If you press the F9 key, you'll see that that changes. So you're all set with that. And then finally, the metalog being specified as a quantile function gives you X as a function of Y. But if you wanted to have Y as a function of X, that's the inverse cumulative. That's not available in closed form, but you can calculate that for anything you want. So suppose you wanted the cumulative probability Y associated with the number 50 at this point. And you simply plug that in there, in that cell, where it is, Y56 here, and it comes back with 0.692 as being the probability associated with it. So that's a complete introduction to this worksheet. Now, let's try a couple of other things. Suppose you said, well, gee, you know, I really, this metalog here is going below zero. I really think that this is a cost maybe that I'm modeling, and it could have a lower bound of zero. So then you could change the bounds from unbounded to a semi-bounded lower metalog. And in this case, the lower bound is zero, and the metalog readjusts itself to do the best it can to go through all the various points. If you want the lower bound to be -5, for example, you could put that in here. And all of a sudden, you'd have a metalog with a lower bound of -5. I'm going to go back to 0 here for this moment. Now, let's suppose these data have to do with the percentage of a population, so that naturally it should be a bounded metalog between 0 and 100. Well, you'd simply change this to bounded. That's the little b there. And now you have a metalog that has a definitive lower bound of 0 and an upper bound of 100. Once again, you could change that. You could change that upper bound to 110 if you wanted to, or whatever you might be interested in. And there you have it. Now you've got a metalog with a upper bound of 110. I'm going to go back and undo that. And then you can also change the number of terms. So for example, here's a 5-term metalog, but if we did the 4-term metalog, which would correspond to this small graphic in the metalog panel, you can see it doesn't do quite as good a job of fitting the data. If you go to a 3-term metalog, it won't do as good a job, but it's still a smoother curve. Let me go back to 5 terms for the moment. Now, what happens, for example, if you did, what if the expert only gave you his 10, 50, 90 points, but had not given you these other 3 points? Let's just delete those other 3 points and see what happens. Ooh, you got an error message. So any error messages are always displayed here, and it says that n, the number of terms in your metalog, has to be less than or equal to the number of data, m. In this case, you only have 3 data. So the problem is you're displaying a metalog with that doesn't actually exist. And so, but if you go down to displaying the 3-term metalog as shown in the metalog panel, then you have exactly a metalog that goes exactly through those 3 points. And if there are other error messages, the spreadsheet is programmed in a way that if there are other messages of any importance, then of course they will be displayed. So that's my brief introduction to this Metalog worksheet. The subsequent videos on particularly the equally likely data Metalog worksheets will build on this one and just show you primarily the differences between this worksheet and the equally likely data ones, where we're pretty much going to calculate these probabilities instead of having to input them, and you can just put your equally likely data here. I'll show you that on the next video. Thanks a lot. I hope you have a good day. Bye.